How's it going, y'all? Ryan De La Garza here, and we're going to do another Desmos Build Along. So in this one, we're going to look specifically at animation on the graph component and how we can use that graph component also for correctness checks outside of the computation layer. So let's check out what we have and what we're going to be working with. So we have this activity, we have 2 points on the graph, and we want to create a function that goes through it. So when I do 2x plus 2, I can see boom, boom, line goes through, I get some check marks, I get some great visual feedback here with what's going on. So let's dive in how we're going to do this. Remember, if you want to build along, you can use the link below to build along with us. On screen 1, everything's set up for you, the question's ready, your components are there, you just need to fill them out. I'm going to be building on screen 2, and then screen 3 is a completed build with notes on everything we did and what's going on. So let's jump right in. First thing, let's look at the meat of what we want kids to do. We want them to be able to input a function and the math input, and I want that to appear on the graph. So that's the first thing we need to accomplish. Before we do anything, I'm going to label my components. I'm going to do input 2 and graph 2 because I'm working on screen 2, and I always like my numbers to match the screens, helps me stay organized. So let's create that function and pull that over first. So in my graph, I'm going to do f of x because that's going to be the function that the students are going to enter. I'm going to go ahead and add a slider because my component is going to define this for me anyways, so I don't need to worry about that. I'm going to come to my graph computation layer, and I'm going to do function f, and I'm going to make a simple function out of input 2's latex. Input 2.latex. So let's zoom in on what we're doing here. What I said is I'm going to look at whatever is in input 2, and I want to make a function out of that. So whatever the students put in there, we're going to turn that into a function, and I'm going to define function f in my graph by whatever that is. So kind of working backwards, I take whatever's in input 2's latex. Latex is just a way of saying the computer's math type. So I'm going to put that latex, I'm going to turn that into a function, and I'm going to define my function f in the graph with that function. So that's what we're doing here in this computation layer piece. So now if I come out and take a look at it, if I put in 2x, I see that appear. I put 2x plus 2, boom. So step 1, check. We've got the function pulled over from the input into the graph. But we don't have a purpose, right? Remember in the original one we said there's 2 points. I need my function to go through those 2 points. So let's make those 2 points. I'm going to do it with a table. So remember, you can type the word table, and we get a table. And I'm going to use the x values of not negative 1. Let's do -3 and 1. Now, I could go and I could calculate in my head what I want this to be, or I could come to the top of my table and say I want to take x1, I want to multiply by 2 and add 2. And now I have my values. Now, since I want the line to pass through it, I'm going to long click and long press this, and I'm going to change these to open circles so we can kind of see it go through. Because I know down the line I want to have those check marks, and it's like the points fill in when you pass through it. So now we have something that's really here. I have these 2 points. I want to create a line that goes through it. And if we stopped here, this is still a great screen. We have some great visual feedback for students. They can adjust the line in real time as it goes through. But we can polish it up a little bit and make it look a little fancier with some animation that really makes things exciting. So let's talk about the animation first. To make that animation happen, I'm going to take my function and I'm going to play with its domain, right? And what we see domain-wise. So I'm going to say -10 less than equal to x less than equal to 10. So this is saying I only want to display this function between these x values. So if I change this to 5 or 2, notice I'm shortening my line. So this is how I could show only a specific piece of that line. So here's what we're going to do for this one. We're going to make that top number, 10, a function of time. So remember, when we press a button and we submit this, it kicks off a timer that goes from 0 to whatever number we want it to. Okay, so I'm going to use that to create this animation because we're essentially going to say I want it to be -1, then 0, then 1, then 2, then 3, then 4, then 5, and it's going to slowly grow as time increases. So let's take a look at how we're going to make that happen. To think about this, we're going to look at our time as it relates to position, and we're just going to pull up a table and we're going to do some middle school math here. So I'm going to have my time go from 0 to 5, right? So as the timer counts from 0 to 5, when it's 0, I want my position to be at -10. But when it's 5, I want it to be at +10. So what's the function here? What's the relationship? Well, if we pull some kind of change in y over change in x, I can see that my function of position as a function of time is going to be represented by the equation 4t minus 10. So I can take that time value, multiply it by 4, subtract 10, and I'll get the position. This equation is going to become our maximum. So when I make this 4t minus 10, and I make a slider for t, let's go from 0 to 5 like I did in my table. Now check what happens when I play it. I hit play, boom, there's the animation as that value goes across, right? So that's how we can use this time function to kind of set and create that animation. And that's how all the animations are created using the Desmos graph. It's all about time and referencing that and creating functions around that. Now, I set t equal here, so we need to go to our computation layer and we need to make it equal to that time since submit. So I'm going to come in here to my graph computation layer and I'm going to do number t is equal to my input 2's time since submit. And I'm going to put 5 here because we're going, our function is set up from 0 to 5. And I did that because I knew I was going to go from -10 to 10. So that was going to be 20. So I picked a number that would give me a nice coefficient on that function. That's why I put 5. But you could put any number you want in here depending on what you want to show. So zooming in on what we have here. I'm going to take the time since that button has been pressed for input 2, and I'm going to have it count from 0 to 5, and whatever that number is, that's going to be our number t in the graph component. So that's what's making it work. So let's preview what we have so far. If I do 2x plus 2, I can now see, boom, boom, it's getting pretty cool, right? We have the animation. So let's come in and let's talk about correctness now. I've done some videos in the past, and you can see the link I'm going to put up right here on how to check correctness for a function in the computation layer, and we could put that in our input. But we can also check correctness in a graph using some little things, and it lets us do some other pieces. So I'm going to come into my graph component, and we're going to check it in the same way that we would in a computation layer, where we're going to do an evaluate at, essentially, where I want to evaluate my function at certain values and see if they're true. So what we're going to do is I'm going to say check 1 here, and I'm going to open up my squiggly bracket because I'm going to say when it's true I want it to equal 1, otherwise I want it to equal 0, but I have to put in the conditions here. So I'm going to say when that function at -3 is equal to -4, I want it to equal 1, otherwise 0. So what I said here is that when the student's function, if I plug in a -3, if it equals -4, then the value is going to be 1. Otherwise, it's going to be 0. So that's my first check, and I just did that first point. So let's make a second check. I'm going to do check 2 equals f of 1, because that's our second point. When that is equal to +4, I'm going to say I want that to be 1, otherwise 0. And so when you're using these conditionals, this colon is saying that's what I want it to be, so set it equal to. So when f of 1 is equal to 4, I use my colon to say I want this variable to equal 1. And my comma is like the otherwise, right? And you can set up multiple conditions in these things, but I'm not going to go into that right now. Okay, so if we test this out, right, if I want to put in some values to see, if I, let's see, delete this so I can show you here. If I say x plus 3, let's make it equals though, I can see here that my second check is true because with this function x plus 3, if x is 1, my y, my function, will be 4. So that gives me a true value of 1, but this bottom one is 0. But if I do make it 2x plus 2, you can see now they're both 1. So that's the check that I'm looking for. But to combine this for my correctness, I'm going to do one last thing. I'm going to say c equals c1 times c2. And what this is going to do is going to multiply out both of these together. It will only be 1 if both of them are true. So that's my ultimate correctness check. So if I come in here and put like x plus 3, notice I have first one's false, second one's true. So my correct overall becomes false because they're not both correct, right? So that's what I'm looking for, and that's how we're setting that up. So now I can add that correctness check to my computation layer. So let's jump in and do that. I'm going to go to my input 2, and I'm going to put correct. And since it's defined in the graph, I'm going to say when graph 2's number C is equal to 1. So whenever that C, that ultimate correct check, is equal to 1, this screen is going to be correct. So let's test it out. I put 2x, I get incorrect, 2x plus 2, right? Ooh, I get a dot. That means that there's nothing wrong yet, but it's not fully correct. If I want to get that check mark, I got to add one more piece. I go to my graph component, and I need to tell it to read only true. Desmos is looking at all the components, and since you can manipulate the graph, it's going to read that as well. So what this line is doing is saying, ignore this when it comes to correctness, and just read it as true. So now if I put in 2x plus 2, there's my check mark. So we have that piece in. Okay, so test yours out. If you're building along with us, make sure everything's working so far before we do this last piece. So the last piece is really getting the bells and whistles in here, and it's those 2 points that had the check marks, right? So if I come in here and I had that first point at -3, -4, right here, and I'm going to label it, I'm going to right click so I can get my emojis, and I'm going to put my check mark, and I moved it left and made it large just so it was big. And my second one was at 1, 4, right there, and we had the same thing. I'm going to copy paste that check mark into my label, and I'm going to make it left and large, and I'm going to make both of these purple since my points are purple. But I don't want these to appear all of the time, right? First of all, I only want it to appear once the line has passed through it, and I only want it to appear if it's correct. So for the first one, that's easy. I can say, all right, I only want this to show up when C1 equals 1. So this is only going to pop up when C1 equals 1. My second one, I'm going to do the same thing, but I only want it to be when C2 equals 1. So these are only going to show up if both of those are true. So let's preview what this looks like. If I did x plus 3, I can see that that's checked. If I do 2x plus 2, I can see that they're both checked. But it kind of takes away from the fun of it if they're both there already. So I only want it to appear when the line passes through. So let's come in here. We're going to add one more conditional statement to here. I'm going to pull that function from here, right? Because this is our function, a position of the line over time. And what I'm going to say is I only want this to appear when this function is greater than or equal to -3, my x value, because it's going through and it's counting. So it's going to do the line. And so once that time value or that x value passes -3, that's when I want this to pop up. And I'm going to do the same thing here. And instead of this, which value am I going to use? My x value. So I want it to be +1. So now let's check out how this works. 2x plus 2, we see the line go, check, check, boom, got it right there. So I know there's a lot to unpack in this video, and we're showing a lot of cool things going on, but you have some great stuff with bringing in functions from an input value, looking at correctness, having that piece checked in the graph, adding the animation pieces, and then also those conditionals to make certain points appear. So there's lots of great stuff that can be pulled off and applied and used in a bunch of different ways. So hopefully you found some great pieces that you can add into your Desmos activities to really kick it up a notch and add those nice polishing pieces. So if you have any other questions, drop them in the comments. Let me know. Thank you guys for watching, and happy Desmosing.